Okay, in this problem, you were asked to integrate or find the antiderivative for this function right here. We can rewrite that if we want by factoring a 2 from the numerator just to make sure that nothing cancels out in the denominator, that we don't have a hole in this function. This trinomial factors into x minus 5 times x plus 3. We still have this x plus 2. And this leads to the idea that we're going to use partial fraction decomposition to rewrite this function. So if the function is x minus 1 over the product of these three binomials, partial fraction theorems say that this can be rewritten as a over x minus 5 plus b over x plus 3 plus c over x plus 2. And if you multiply through by the LCD, this is what you get. And you could multiply all this stuff together and equate coefficients, but it's always worth trying this. We let x equal 5 everywhere in this statement. For example, the second two terms on the right become 0. And we get 4 equals 56a, so a equals 1/14th. And similarly, if we had let x equal -3, the first and the last terms turn to 0. We get -4 equals 8b. So b equals -1/2. And finally, if we let x equal -2, we get c equals 3/7. So this part right here can be rewritten this way based on these values right here. So a over x minus 5 minus 1/2 over x plus 3 plus 3/7, which is c over x plus 2. Then take the antiderivative term by term. You could use u substitution, but in the end, you'll see that the antiderivative of this first term is 1/14th times the natural log of the absolute value of x minus 5, minus, same deal here, 1/2 times the natural log of absolute value of x plus 3, plus 3/7 times, oh, I forgot to put brackets here, the absolute value of x plus 2. Now you could distribute the 2 if you wanted to, and you could even use some properties of logarithms to collapse these three terms into one, but it doesn't really improve what it looks like. So that's your antiderivative right there. And here's kind of how you prove it on Desmos. Here's the answer, where I actually distributed that 2 sitting out front. I disabled the graph of f of x. But the idea is that if you take the derivative of f of x, big F of x, you get little f of x, which is the function that we started with. And that's what this graph is right here. But I also have graphed f prime of x, the derivative. These two should be identical. And you could visit the graph and disable these one at a time, and you'll see that the graphs overlap. Okay, so there you go. That kind of proves that that's the answer. If you have any questions, post a comment.